Welcome to my presentation. In this presentation, we shall see vector operations in two dimensions. We will see some of the properties related to vectors. So the first property we want to talk about is as follows. Magnitude of a vector. The way to represent the magnitude of a vector is as follows. If V is a vector, and if we have AI plus BJ as the representation of that vector, then the magnitude of that can be written out as V. The magnitude of magnitude of vector V is going to be equal to square root of A squared plus B squared, like that. Okay, that is how we can represent the magnitude of a vector. The second property is telling us if V is a vector, AI plus BJ, and if we have another vector W which has CI plus DJ, then the following properties are true. Then vector V plus vector W, we can write this as AI plus BJ, that is AI plus BJ plus CI plus DJ. Therefore, we can combine similar looking terms and then write this out as A plus CI plus B plus DJ, and therefore this is what is called the addition property of vectors. This is the addition property. Addition property. Similarly, we can do the subtraction property, and if a vector V is AI plus BJ and vector W is CI plus DJ, then vector V minus vector W, we can write that as AI plus BJ minus CI plus DJ, isn't it? So we can therefore write this one as AI minus CI plus BJ minus DJ. Therefore we can write this one as A minus CI plus B minus DJ. This is what is called the subtraction property. Subtraction property. We will use these properties to solve some simple examples in my other presentations. The third property, the other property, if V is a vector AI plus BJ and W is another vector CI plus DJ, then the scalar multiplication, if then C times a vector is going to be C times AI plus BJ, like that. So the way we can write this one, expand it out, is by distributing the C to every one of the terms inside the parentheses, C times AI plus C times BJ. And this is what is called the scalar multiplication. This is the scalar multiplication. Scalar multiplication property. Okay. So these are some of the properties. There are some more properties. We will look at the next property we want to look at is scalar product or dot product. Let us see how that product is going to look like. Let me write that here. Scalar product, scalar product or dot product, also sometimes called as dot product. And in here, if V is a vector, AI plus BJ, and if W is another vector, CI plus DJ, then the scalar product or the dot product, which is written as V dot W, like that, is equal to AI plus BJ dot CI plus DJ. And then using the FOIL method, we can expand this one out. FOIL method is nothing but we go to expand the first terms, expand the outer terms, expand the inner terms, and expand the last terms. That's what it means. So AI times CI, then AI times DJ plus BJ times CI plus BJ times DJ. Okay, and then since I dot I is equal to 1 and J dot J is equal to 1 and I dot J is equal to 0 and J dot I is equal to 0, since we know this information, we can simplify this as follows. AI times CI is going to be equal to AC, then AI times DJ, this is going to go to 0, BJ times CI, that is going to go to 0, and what is left here is this is plus 0 plus BJ times DJ will be BD. J dot J is since J dot J is equal to 1. Therefore, we can write this one as AC plus BD. Therefore, the dot product of these two vectors is going to be AC plus DC, like that. Okay. One other property of vector operations is we can also find the measure of those angles. We can find the measure of the angle between these two vectors. Okay, if V is a vector and if W is another vector, and if we had two vectors like this, if this is vector V and if this is vector W, and the angle between these two vectors, if we represent that as theta, we know that cosine theta is equal to vector V dot vector W divided by the magnitude of vector V times the magnitude of vector W, the magnitude of vector W. Okay, so these are some of the properties related to vector operations in 2 dimensions. In my next presentation, we should look at some examples related to properties of vector operations.